Good day, students, classmates. Al Braswell here. This is our second meeting for what used to be an MN 140 course. It is now called, I think, MECH 1340. And what this course is about is we'll call it, let's call it circuit switching. Some people like to call it, what can I say, ladder logic. Boolean logic. And a few other titles. For us, I guess we'll call it Boolean logic, or the introduction to logic. Circuit switching, okay, and ladder logic. Where does that come from? If you recall, generally in manufacturing operations, we have a circuit. Power comes in. We have three main power contacts. That goes to a motor. Right? Okay. And we have to have a control circuit. The control circuit is what switching logic is about, ladder logic is about, Boolean logic is about. So you're probably familiar with this. We tap two lines. We go to the primary of a control transformer. We take off from the secondary of that control transformer. And normally we'll have what we call, let's call it line one, okay? Line one, and in modern times today, we have a neutral on the other side of the secondary of the transformer lines. I'll bring that down, and the reason that we call it neutral is because we ground it. Now that all of our logic that controls this motor right here, this is our ladder logic, this is our Boolean logic. Electricians will call what we're looking at right now, the diagram we're looking at right now, ladder logic. You may have a few technicians and engineers that will call it the switching logic, the Boolean logic. Regardless, that is what we are here to talk about, is what takes place down here. So let's see if we can get something that we're all familiar with here. I'll go ahead. Well, let me give us a little room here. I've got an eraser here somewhere. I'll run my wire over this way so we can sketch a little bit more easily. And what I'll have is a normally closed push button. And then I'll have a normally open push button. And I will have the coil of a relay right here. And we'll say we'll use this relay, this contactor, for the motor. Okay, so we'll call this, let's call it forward, and let's call this one, this push button right here, to start, and we'll call this push button right here stop. Now then, I think you guys are going to find yourselves familiar with this. You've seen it before, but let's press forward with this thing. So I have a latching contact or a sealing contact, whatever you like to call it. And this coil has these three main contacts mounted on it, which actually apply the main power to the motor and make it turn. But everything down here is going to be, let's make it 24 volts in the secondary. Okay, so we've got 24 volts down here, and we've got 460 volts, three-phase right here. Okay, so whenever this coil is energized, okay, by our circuit down here, these three main contacts will close. When they close, okay, the motor will start. And we've assigned it a forward direction, so this has the same name. No confusion there. So here's what we can say about the logic down here in the control circuit. This motor will start whenever this coil is energized. This coil will be energized, and by the way, I've got to call this forward also. This, and these are all part of the same device. So anytime this coil is energized, these three main contacts will be closed, and this latching contact or sealing contact will also be closed. Okay, now if you recall, the purpose of this contact right here is so that once I push this button, this coil energizes, this contact closes. I now have a path for a current through this normally closed push button, through the sealing contact, and through the forward coil. And while this button is pushed, I will also have current flowing this way and this way. Okay, so let me put that in a different color. So my current coming through there, and through there, and through there, while the start button is pressed. When I release the start button, okay, I lose that path for current flow. And now I have current flowing through the stop button, which is normally closed. It will come down and go through the forward auxiliary contact because I had pressed this button and this coil closed it, and the current will finish flowing through the coil itself into the neutral wire and to this side of the transformer. Okay, that's not a 4, that's supposed to be an arrow. Okay, so pretty simple, huh? This is like a starter kit you would buy, and you find them hanging on a roof column, normally throughout a plant for blowers, for exhaust fans, usually for motors that are going to run in one direction, and they do an important task, but they don't do a huge task in the manufacturing of a part. Now why do we have to get back, or why do we want to talk about Boolean logic and ladder logic? And I'm going to stick to Boolean logic for a while. In fact, I may just adopt that in my lingo for the rest of this course. Well, what we can say that we can say that forward is on when I have these conditions met. When stop not pressed, and I believe that's all we've got, right? No, it's not. Okay, no, it is not. Okay, so when forward is on when stop is not pressed, and when start has been pressed, and oops, I'm making a mistake. Gotta be careful. Or when our latching contact is closed. Okay, so the motor will be running. In other words, forward is on. If forward is on, that motor is going to be turning unless you've got something mechanically wrong. So forward is on when the stop button is not pressed, and when the start button has been pressed, or when the forward auxiliary contact is closed. This is what we call, or this is a form, or this is an English language statement of a Boolean statement. And I'm going to write that right now, okay? So, in Boolean logic, we will say that forward is equal to stop. Now then, I'm going to put a bar over the top of it, which means that I have not pushed the stop button. And put a parentheses here, start has been pushed, or the forward auxiliary contact, and I'll do auxiliary right here, has been closed. Okay. To be more mathematical about it, I will say that, and let me get a green marker here. Time for a change, right? Forward is equal to stop. Now the bar means negated. The bar means not stop, or stop not. Okay, not stop, stop not, same thing. And now this we'll leave this with and, okay, for the time being. And start. Okay, start has been pushed, or I've had the forward contacts closed somehow. Okay, so very simple motor circuit. It runs only in the forward direction. We have a control transformer. Okay, 24 volts in the secondary, that's safe voltage. And you know, whenever you have a neutral, you should see a line 1 and a neutral marked in the secondary. And current will flow through these paths that I've shown you here. I must have erased one, right? So I'll put it back. Okay, and this current path, if I don't push that start button, or if I press that start button, if I don't press the stop button and I do press the start button, or the forward contact has already been sealed in, then the forward command will be issued. Okay, and this is the forward command down here. So that is our introduction to logic. Okay, what I want to do is I want to dress this up, and let's put it into a simple math form, so that all of this gobbledygook I've got right here, so that you can see that the gobbledygook can be written more simply if I make it a math form. So take a look at that. If you've got questions, you can talk to Alex. Okay, you can send an email to me. But that will be it.